Picture this, a huge family dinner, plates are clattering, everyone's having a great time, and then the check arrives. Suddenly, it's total chaos. Who ordered the extra fries? Who has that 20% off coupon? And who forgot their wallet again? I'm a sixth grader, and my classmates and I were given exactly 18 days to engineer a complete solution to this exact problem using math code, and honestly, a whole lot of empathy. Today, I'm going to walk you through our actual project journal to show you exactly how we built an app to literally save family dinner, taking you from our very first messy brainstorm all the way to our official App Store launch. So our teachers didn't just hand out some boring syllabus. No way. They launched us into total chaos. They actually set up a mock restaurant right inside our classroom. We had parent volunteers acting as servers, bringing out food, and then dropping these massive, super complicated bills on our tables. It was honestly the perfect entry event. We immediately felt the real frustration of trying to calculate who owed what while our food was literally getting cold right in front of us, and that led us straight to our driving question. What system can we, as tech developers, develop for an extended family to split a restaurant bill fairly? At that moment, we weren't just students anymore. We were problem solvers. When we started breaking down the data, we quickly realized our system was going to have to handle a ton of edge cases. I mean, it wasn't as simple as just dividing the total by the number of people at the table. We had to build actual logic for a nuclear family of 4 paying jointly, apply a 20% off coupon for a solo diner covering their own stuff, and then my personal favorite, figure out how to charge simple interest to that one uncle who always forgets his wallet and promises to pay you back later. It was this beautiful mathematical puzzle, but before we wrote a single line of code, we really had to stop and think about the human element of all this. We use a voice-to-text tool called RiffBot to reflect and ask ourselves, how does it actually feel to share expenses fairly? What could help make this whole process smoother? Because here's the thing you learned pretty fast. Technology that lacks empathy usually fails. We realized that sharing expenses isn't just a math problem. It's a deeply emotional one. People get stressed out, they feel cheated, or they get embarrassed. We needed to design an app that didn't just crunch the numbers perfectly, but actually made this social interaction smoother and way less awkward for families. Section 1, Leveling Up Our Math. On days 3 through 7, we had to go super deep into equivalent representations. We had to learn how to seamlessly convert between fractions, decimals in both terminal and repeating forms, and percentages. We tackled personalized IXL study plans to drill down on our weaknesses, and we even hosted perplexity space review sessions to test each other on story problems. We're talking sales tax, discount tips, simple interest, the whole shebang. Then by day 8, things got real. We didn't just take some boring paper tests to prove we knew the math. Nope, we took a field trip to a real local restaurant. We sat down, ordered, and actually had to practice our new computation skills. It was our very first test of doing mental math out in the wild, surrounded by actual restaurant noise, servers walking by, and all those real-world distractions. Section 2, Designing a Better Solution. So having survived the big math field trip, we finally had the foundational knowledge we needed under our belt. It was time to shift gears from being mathematicians to acting like real software architects on day 9. We grabbed the receipts from our mock entry event and used them to test out existing billing apps that were already on the market. Honestly, the existing apps were super confusing. They completely ignored the whole coupon problem, and they were just way too rigid. That's exactly why we outlined our dream app to be something totally customizable, capable of handling those weird family cases, and most importantly, incredibly user-friendly. But to build that dream app, we had to learn exactly how the pros do it. On day 11, we even got to interview a guest expert parent who actually works full-time in the tech industry. They showed us that real developers don't just sit down and start blindly typing on a keyboard. No way. They plan, they iterate, and they follow a deliberate process to absolutely ensure their artifacts solve users' actual problems. So from day 12 to 15, we lived and breathed that design process. First, we got crucial instruction from our Tinker Lab teacher on all the tech logistics. Then we used graphic organizers to storyboard and literally sketch out our app designs on Canva. It wasn't just about the pure logic, it was about visual art too. We wanted to engineer a beautiful solution to our problem. So, our art teacher came in for a special guest lesson to help us solve visual problems. We wanted to make sure our user interface looked beautiful and felt intuitive, and it was only after all that planning that we finally moved on to selecting our coding platform. Section 3, Coding the App. With our beautiful storyboards in hand and our math formulas totally perfected, the energy in our classroom was just electric. Days 15 and 16 were an absolute blur of focus. Teams selected platforms like Base 44 or Figma to actually build their apps. We had to learn how to use AI prompting effectively to help generate our foundational code structures, and let me tell you, the hardest but definitely most satisfying part was translating the raw math we mastered back in week 1 into something that the computer could actually understand. We relied heavily on each other, finding growth and strength from collaboration. We would just hand our device to classmates and say, "Hey, try to break my app." Finding and fixing a flaw in the logic was like solving a really good mystery. Section 4, Testing in the Real World. In STEM, peer review inside a quiet classroom is definitely not the final exam. The ultimate test of an artifact isn't on a piece of paper. The ultimate test is live, which brings us to day 17, the ultimate family dinner. Our teachers organized this incredible evening event at a local restaurant where our families came out to dine together. We provided these cool conversation starter cards to help families really connect, but the real main event happened at the end of the meal. Over the course of 1 or 2 hours, our families used our newly coded apps to calculate their real bills, tips, and taxes in real time. Watching my own extended family successfully split a super complicated check using an interface that I designed was literally the best feeling in the world. Which brings us to the final day of the entire project, day 18, launch day. We kicked off the morning with team meetings to process all the feedback we gathered from our families at the restaurant the night before. We used that to make final revisions to our code and our user interface, and then we did it. We published our finished bill-splitting apps straight to the App Store. Going from being totally overwhelmed by a messy pile of receipts to being published tech developers in less than a month was an accomplishment that just filled us with so much pride. How does learning fundamentally change when the problem you're solving is actually real and the solutions are creative and authentic? For my 6th grade classmates and me, it literally changed everything. Learning fractions wasn't just some boring chore anymore. It was a literal key to making our app function. Coding wasn't just staring at a screen. It was building a real tool to help our families enjoy their time together without stressing over the check at the end of the night. When you learn by doing and when you build solutions for the real world, you gain the power to actually change things for the better.